Hello everyone, welcome back to my next video, pH partition theory. So the pH partition theory also comes under the factors affecting physicochemical properties of the drug when the drug is in solution form. Already I discussed in the factors affecting mainly the physicochemical properties of the drug when the drug is in solution form. So when the drug is in solution form, to get absorbed, the drugs pKa and drugs lipophilicity plays an important role. So this theory interrelates the pKa of the drug, lipophilicity of the drug with that of drug absorption. So what is pH partition theory? Theory interrelates pKa of the drug, lipophilicity of the drug with that of drug absorption. So this theory relates and explains the GI absorption of drug as well as mechanism of drug absorption. So there are some assumptions or hypotheses according to this theory. So what all those assumptions of pH partition theory is? First of all, GI barrier is a simple lipid barrier. This is the first assumption of the theory. And the second assumption is that unionized form of drug gets absorbed in the GI barrier. So unionized form absorbs more, and the drug where it will get unionized, that is acidic drugs absorbs from stomach, whereas basic drugs absorbs from intestine. And the last assumption is that more lipophilic the drug is, faster is absorption. So according to the pH partition theory, mostly unionized drug as well as lipophilic drug absorbs more. So usually we say the absorption is maximum for unionized form of drug, as the membrane is lipophilic in nature and lipophilic form of drug absorbs more. So that is the hypothesis of pH partition theory. So these are all the different points of assumptions of the theory. The first assumption is that GI is a simple lipid barrier, and the second assumption is unionized form of drug absorbs more. So unionized form of drug means acidic drugs gets unionized in stomach pH, so absorbs more in stomach, whereas basic drugs absorbs more from intestine as it is unionized at that pH. Whereas more lipophilic the drug is, faster will be the absorption. So when the drug's lipophilicity is higher, that is partition coefficient is higher, then absorption rate also will be faster. So lipophilic drugs and unionized drugs gets absorbed according to the pH partition theory. So these are all assumptions. It's not actually experimentally proven. So these are all the predictions that from ionization the absorption reduces, and during unionization of the drug or unionized state of the drug gets absorbed more. So is it true? Is it experimentally proven? Is it the data has been observed experimentally or not? So you have to compare the theory as well as with the observed data. So let's see the experimental values of these theory assumptions, whether it is relating or not. So for studying this pH partition theory, we are taking example of one drug from weak acid and another drug from weak base. So which drug we are taking here? We are taking salicylic acid as example for weak acid and ephedrine as weak basic drug. So the pK of the drugs are, for salicylic acid the pK is 3 and for ephedrine it is 9.5. What does it mean? For a weakly acidic drugs whose pK, that is for example salicylic acid, its pK is around 3. That means ionization of salicylic acid takes place at pH 3. And before 3, that is in pH 1 and 2, they will be in its unionized state. So the absorption should be maximum between the pH 1 to 3. That is 1, 2 should have maximum absorption of salicylic acid, and from 3 as ionization starts, so 3 to 14 or 3 to 8 which is the physiological pH, or 3 to 14 if you consider for a pH, the ionization continues, so the absorption should be lesser according to pH partition theory. Similarly, in case of ephedrine whose pK is 9.5, so ionization takes place from 9.5. Before 9.5, that is from 1 to 9, the drug starts ionization from 9.5, and after that, that is 10.5, then up to 14, the drug will be in its unionized state. So unionized state, so the absorption should be maximum within this, and at 9.5 and below that the ionization starts, so the absorption rate should be lesser in case of ephedrine. Is it so experimentally? That's what we have to determine. When you see the graph experimentally and the predicted value according to the theory, so it is the pH. We are preparing different pH solutions from 1 to 14, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So here we are considering rate of absorption, that is 50% and this is 100%. According to the theory, the salicylic acid must be absorbed maximum in the pH 1 and 2 because ionization starts from the pH pK 3 because pK of salicylic acid is 3. So ionization starts at this pH, so as it gets ionized, the absorption should decline from the pH and it should go on decline till this pH. This is according to the theory for salicylic acid. Whereas for ephedrine, that is weakly basic drug whose pK is 9.5. So the pH 9.5 for ephedrine. So at pH 9.5, the drugs, so absorption rate should be reduced. So the inflection point, that is the dip in the curve, which is known as inflection point. Inflection point is nothing but the reduction in the absorption. Why the reduction in absorption observed in theory? Because of ionization. So ionization takes place at pKa, that is 3 in case of salicylic acid and 9.5 in case of ephedrine. So the ionization starts, so there will be reduction in the absorption rate, which will be shown by this inflection point, that is the dip in the curve because of reduction in absorption. This is predicted by the theory. But what happens actually when experimentally placing salicylic acid or ephedrine between the pH of 1 to 14, what happens? How the drug absorption, what is the rate of drug absorption takes place? Is it the maximum rate before the pKa or after pKa for weak base? Let's check. For salicylic acid, the inflection point took place at pH 8. That is, before 8, the drug is unionized and the drug was completely absorbed or absorbed maximum before pH 8 also in case of a salicylic acid, and for weak base, and this dip point was taken place, that is inflection point took place at pH 6.5. So the inflection point should be at the pKa 3, whereas it took place at the pH 8 for weak acid. Similarly, in case of ephedrine, it should have inflection point at pH 9.5, but it had at 6.5. when it has been experimentally done. The observed data showed shift in the absorption rate at different pH. For weak acid, the shift has been taken from left to right side. So for acidic drug, there was shift towards right side, and for basic drug, there was shift towards left side. So what might be the reason? That we have to discuss in the deviations of this pH partition theory. So summarizing the theory is, we have taken example of a weak acid and weak base. So for weak acid we have taken example salicylic acid, and for weak base we have taken example ephedrine. Salicylic acid's pK is about 3. That means the ionization should take place at pH 3, whereas the pK of ephedrine is 9.5. So the inflection point should take place at this pH, but the inflection, it was expected to inflect at pH 3 and pH 9.5 in case of salicylic acid and ephedrine respectively, whereas the inflection point took place at pH 8 in case of salicylic acid. That is, the absorption was maximum before the pH 8, that is 1 to 8. Throughout the physiological pH, the salicylic acid was uniformly absorbed, whereas in case of ephedrine, it was expected to have inflection point at 9.5, but inflection point took place at the pH 6.5. That is, before this there was ionization, that is 7.58. Till that, ionization or the maximum absorption rate took place for this drug ephedrine. So there is difference in the values of observed as well as the theoretical value. That acidic drug has shift of a curve towards right side, and basic curve there was shift towards left side in case of basic drugs. Now what is the reason for shifting of acidic drug towards right and basic drug towards left? So pH partition theory is now, it is not actually a simplified form. So what we are discussing, that unionized and lipophilic drugs gets absorbed. Is it sufficient that only pK of the drug and the lipophilicity of the drug can be considered for drug absorption or oral drug absorption? No. Just considering these two parameters will not be sufficient. It is oversimplification of the more complex process, because oral absorption is not that simple process, it is a complex process. Each and every drug, each and every acidic drug, each and every basic drug behaves differently. So you cannot explain simply that unionized drug and the lipophilic drugs can absorb maximum and their rate of absorption will be faster. So there are deviations from this theory from when you consider the experimental data or the observed data. So why there is deviation? So what are the reasons for deviation? So when there is shift from the theoretical value, there are deviation occurs. So what are the reasons for deviation? This is another important question. There are 3 points why there are deviations in the pH partition theory. So first point is absorption of ionized form of drug. We already discussed, always we discuss that unionized form only gets absorbed, but not necessarily. Sometimes even the ionized form of drug also gets absorbed. That may be the reason for shifting of acidic drug towards right and the basic drug towards left. So the curve obtained generally between the pK and the rate of absorption is shape is sigmoidal shape, which is S-shaped. Just we have shown S-shaped curve. So this curve S-shaped is known as sigmoidal in shape. So sigmoidal shape has been shifted towards right for weak acid and left for weak base. One might be the reason because the absorption can also takes place for the ionized form of drug. We just explained that only unionized form absorbs, but not actually some of the ionized form of drugs. can also get absorbed. Example, in case of quaternary ammonium compound, which is weakly basic in nature, which are having positively charged. So ionized form of drug. So the ionized form of drugs, the quaternary ammonium compound shows very good absorption, because so even they are in ionized state, they are absorbed maximum. So absorption of ionized form of drug is also possible. Now the second point of deviation, reasons for deviation, is presence of aqueous unstirred layer. This layer is also known as stagnant layer. So this is the layer which is present in the near the GI barrier, that is just after the mucosal layer. To protect the mucosa, there is a layer which is known as this aqueous unstirred layer. This unstirred layer is aqueous or hydrophilic in nature. We know that membrane is lipophilic, that's why we consider always lipophilic molecules absorb more. But before this lipophilic membrane, there is a hypothetical layer which is an aqueous unstirred layer. The thickness of the layer can be reduced by mixing this layer. This layer is usually unstirred or stagnant in nature. What is the significance of this layer? Is just to protect the mucosa, either intestinal mucosa or the gastric mucosa. In gastric mucosa, gastric irritation of drugs can be prevented by this aqueous unstirred layer. And in case of intestine, it is present at the villous surface. Where the villi is present, near that villous surface, this aqueous unstirred layer is present. First of all, the drug must pass this aqueous layer, then it have to cross the lipophilic membrane. So even hydrophilic molecules also can absorb. We already discussed about the absorption of drug, that is lipophilic and only unionized form absorbs. According to the first point, ionized form of drug also can absorb. According to the second point, even the hydrophilic drugs can absorb from the biological membrane. Now the third point of deviation reason is microclimate pH. Now what is this microclimate pH? So there may be the difference in pH in GIT when you consider stomach or intestine. So this is the wall of the gastric region and this is wall of intestinal region, and this is the lumen, that is the cavity of the stomach or the pouch, the content where it will be placed. This is known as lumen. So there will be difference in pH between the wall and lumen, since near the walls the cells secrete H+ ions, makes the wall more acidic than that of the lumen. Similarly, the pH in the intestinal wall and lumen, this also has difference. So difference between the surface of the GIT and the luminal pH, this difference in pH is known as microclimate pH. So there are some microclimates present at the surface which secretes H+ ions or bicarbonate ions, making the wall either increase or decrease in pH than that of the lumen. So the ionization depends upon the pH. So the ionization will vary within the lumen as well as at the surface. So there may be deviations in the drug absorption. So these are the points or the reasons why there are deviations in the pH partition theory. So pH partition theory, according to that, unionized and only lipophilic molecules passes. Is it so similar to that of pH partition theory, all the drug absorption takes place? No. Some of the drugs has deviations from that pH partition theory, which can be explained with the example of salicylic acid and ephedrine has been exemplified very nicely, that at 3 pH and at 9.5 pH for ephedrine, the absorption should reduce. Before and after that, the absorption should be maximum. But according to the experimental data, the absorption was well before 8 pH. That is, even the drug, 50% of drug gets absorbed at pH 8 for salicylic acid, and in case of this ephedrine At 6.5, the maximum, till x 6.5, the absorption was maximum in case of ephedrine. So there are deviations. So the reasons for deviations are presence of aqueous unsteady layer, even the absorption of ionized form of drug, and presence of microclimate pH. This is all about pH partition theory. This also have to be included in the physicochemical properties of the drug, and mainly when the drug is in solution forms, because this is the theory which relates pKa and lipophilicity. That is all about physicochemical properties of the drug when it is in solution form, and that affects the drug absorption. Those are all the factors which affects the drug absorption. So you have to consider this pH partition theory. This may come in short notes also, and some points can come in competitive exams like the deviations. What are the deviations, and sometimes the pKa, and where the ionization takes place, and where the absorption will be maximum. Tomorrow or in my next video, we'll discuss about the role of dosage form. Still the factors affecting oral drug absorption is pending. So 3 factors are there: biological factors, physicochemical properties of the drug, and role of dosage form. We completed 2 factors of the drug oral absorption, that is biological factors we have completed, and physicochemical properties of the drug when the drug is in solid and solution state. Now the last factor is role of dosage form, that we will discuss in our next video. Thank you.